Okay, recorded. All right, so I think I'm gonna spend more time on this section 8.2. We're gonna probably do at least one more exercise, and then and then we are supposed to move to this section 8.3, which is a very short section. So yeah, we'll see. All right, so yeah, and of course, just to remind you guys, the second test it's on May 11th, and the final it's May 23rd. And we're gonna have review, of course, before the test and the final. And what else? Yeah. Oh, yeah. So next week I will probably post the review sheet for the second test. So the second test, of course, is gonna cover chapters. I think chapters we have chapters 5, 6, and 7, and probably 8 too. So yeah, so this second test is gonna cover a lot of chapters actually. But anyway, so in the review sheet you're gonna find problems, exercises from each section, right? The same as we had like for the first test, right? So we're gonna have exercises from each chapter and section. All right. So this is section 8.2. Again, this is about estimating mu when sigma is unknown. Right. So let me explain again, guys. So whenever you have like an exercise or problem where you have to find a confidence interval, okay? So let's say you have a problem and you have to find, let's say, confidence interval for the population mean mu or population average mu, right? So you need to read carefully the problem statement, so that we have our two cases. There is a case where the sigma, the population standard deviation, is known. So sigma is known, it's given, known. So but what I mean by known, it's given in the problem, right? Again, sigma, that's the population standard deviation. And the second case, of course, that's when sigma is unknown. All right. So there are two cases. And then when sigma is known, right? So this confidence interval, it's of the form, this confidence interval is just your, it's x bar, the sample mean minus the margin of error E, and x bar plus E. That's what we mean by the confidence interval, okay? So your population mean or population average mu is supposed to belong to this interval. Now, how do we find this interval? Well, first there's x bar. X bar, it's given in the problem, right? So the x bar, it's known, right? So this x bar, it's known, it's given. Or you have a sample and then you can compute this x bar. So this x bar is always given. Okay. So the problem is to compute this margin of error E, right? That's the problem. That's the difference between the two cases. So how do we compute this E? Okay. So when sigma is known, when it's given in the problem, then the E, right? So then the E is given by, so we need to use actually a normal distribution, and this E is given by this Z subscript C. Okay, we are using a normal distribution. This is here, we are using a normal distribution. So the Z, that's the variable of the standard normal distribution, right? So we have z subscript c times sigma over square root of n, right? So that's the formula of E, right? Now, in this formula of E, there is, well, sigma is given in the problem, square root of n, that's the size of the sample, it's also given. So the problem is to find this z subscript c. Okay, so this z subscript c, the c, that's what we call the confidence level, right? You see, that's a probability. It's called the confidence level. And the thing is, to find this z subscript c, all you have to do is when you have your confidence level, okay, then you can use this the table. This is the bottom of the table fee, bottom of table fee, and there you can find for each confidence level C, you can find the corresponding critical value z subscript c. So I'm talking about, let me show you the table. So this z subscript c is given by, yeah, here, by this table here, right here. All right, so it's in the bottom of the second page of the table fee. You see in the bottom to the left, you see there's the level of confidence C, and then there is the critical value, this Z subscript C, right? So if the level of confidence, let's say, is 90% or etc., so all you have to do, guys, is just to take the corresponding critical value Z subscript C. So that's how you get this Z subscript C. Okay. So the only thing you have to do really here is to just to find this Z subscript C. Once you have the Z subscript C, sigma is given in the problem, n is given, so you can compute your E, and then you can compute your confidence interval, right? I'm gonna do one example so you can see how this works. But now, the other case, the second case, right? So we discussed this, sigma is known, that was in the section 8.1, right? This is section 8.1. Now, so in 8.2, so we said, what about the case when sigma is unknown? Okay, so when sigma is unknown, what happens is, it's the same, the idea is the same. It's just that because sigma is unknown, right? The population standard deviation is unknown, we're gonna use the sample standard deviation, not the population standard deviation, because population standard deviation sigma is unknown, right? But we can have we can compute the standard deviation of our sample, right? We have a sample, we can compute the standard deviation, and that will be your S. So instead of using sigma, we're gonna use S, the sample standard deviation. But the thing is, there is a difference here. The variable here is not normally distributed. It's actually the distribution is that this student, it's a different distribution. It's not the normal distribution, right? So it's not the variable z here, it's the t variable. So this is the student t distribution. Okay, so it's not, we are not using the normal distribution. We are not using the variable z, which is the variable of the standard normal distribution. We are using the student t distribution. So the variable here is called t. But anyway, the thing is, again, you want to compute your margin of error E, right? All right, so this margin of error E, instead of Z subscript C, it's given by T subscript C, okay? It's just because we are using different variable. It's not the same distribution, right? And instead of sigma, which was known in the case of the section 8.1, in 8.2, we said sigma is unknown. So instead of sigma, we're gonna use S, the sample standard deviation, right? The S, that's the sample standard deviation. So we have your sample, then you compute X bar of the sample, the mean of the sample mean, and you can also compute the sample standard deviation, right? All right, and then is divided by square root of n. The same thing, right? Here it's divided square root of n, it's the same thing here, right? So S it's given, n is given. So the only problem here is to find this t subscript c, right? Now, so to find this t subscript c, we need to use the table 4. Find t subscript c, this one right here. So we need to use the table number 4. We use table 4. Okay. So to use this table 4, you need, again, you need the confidence level C. Okay. Again, right? And not just confidence level, you need what we call the degree of freedom. Degree of freedom, which is just n-1. Just a fancy word for n-1. So this is degree of freedom, which is n-1. Okay. So let me show you again this table, table 4. Right. So this is our table 3. Now next table, that's the table 4. Okay. So as you can see in this table 4, there is this, the first column, there is this degree of freedom. That's n-1. N is the size of the sample. N is given, right? And then next to the degree of freedom, you have your C, right? So in the top, again, forget about the first 2 rows, okay? In the third row, you have this D dot F dot. That's the degree of freedom. And then next to D dot F dot, there is C. That's the confidence level, right? And then you have like 0.500, 0.750, etc., etc. So yeah, so that's your confidence level. Right. So let's have at least, well, 2 different examples. So the first example, let's say sigma is unknown, and the second example, sigma is known. All right, and just so you can see the difference. All right. Exercise or example. So let's start with an exercise from section. Let's start with the 8.2. Okay, because I think probably well, let's see. So for example, exercise 15, page 395. Right. So in this exercise, we have the following. It's about mountain lions. Okay, so how much do wild mountain lions weigh? Etc. So we have a sample of I think 6. How many? 6. Yeah, a sample of 6 mountain lions. So we have this sample of 6 mountain lions, and their weights is so their weights are the following. So the weights are in pounds, of course. In pounds are, so we have 68. There is 104, 128, 122, 60, and then 64. All right, so we have this sample of 6 mountain lions. Their weight are like 6. First line is actually its weight is 68 pounds. Next one is 104, etc., etc. All right, so then it says, well, because you have this sample, then you can compute or check. So this is from section from chapter. So this is chapter 3, right? In chapter 3, we discussed how to compute, X bar and S. Remember the average sample mean and the sample standard deviation, right? This is from chapter 3, actually. Okay. So the question is to check that X bar is, so the sample mean.
Do we need to find the average?
Say again?
Do we need to find the average of
Yeah,
the
that's it. Yeah, yes,
of,
absolutely.
of
So
those
that's the
weights.
average. Yeah, yeah, the
It's
X bar.
91.
Yeah. Yeah.
It's
So
91.
yeah. So the average, yeah, the sample average or the sample mean X bar is equal to, so we need to check that the X bar is 91.0, 91 pounds. And S, the sample standard deviation is approximately, I think 30.7 pounds. Okay, pounds. All right. All right, so this is from chapter 3. I mean, there's nothing new here. Okay, you're supposed to know we have a sample. You know, we have here we have 6 data values. So you know how you're supposed to know how to compute the X bar and the S. This is from chapter 3. Okay, there's nothing new here. And yeah, so for example, X bar, to compute the average, you know, just take the sum of all the data values, like 68. You know, plus 104, plus 128, plus 122, plus 60, plus 64. You know, just the average. We have 6 lines, so it's over 6, right? So X bar is equal to, let me see the top. The top would be, just make sure that I have the right answer here. The top is actually equal to, yes, 546. Yeah, 546 over 6, right? So that's 90, that's exactly 91. Yeah, that's 91.0 pounds. Okay. So that's how we compute the sample. And again, we discussed this in chapter 3. All right, now for the S. I know some of you have trouble with this S. It's not, I mean, it's not easy as the X bar. So now, want to compute S, right? All right, so there are 2 steps. So first step, we are supposed to compute the S square, the variance, right? So we said the variance. Let me just remind you the formula, and then I will give you in details the computations. Okay, so the formula says the following: this is the sum of X minus X bar, and then you take the square over the whole thing over n minus 1, right? So what we are supposed to do here is you take the first value, which is 68, right? Take 68, and then you subtract the X bar, right? That's what I mean by X minus X bar here. X is supposed to represent your data value. You take your data value, which is your X. This is your data value. And X bar, that's your sample mean. That's the average, right? So you take the difference between your data value and the average. So your data value, first data value, for example, is 68. So I'm going to take 68 minus the average, which is 91. And then we take the square, right? And then this is a summation. This capital sigma, this is a summation. So it's a sum. Right? This is capital sigma. That's a summation symbol. Okay, so it means we're gonna have a plus, and then we do the same thing with the next data value. Next data value, it's 104. So I'm gonna just take 104, subtract my 91, and then take the square, right? Plus, next, so next is 128. So I'm gonna write down here. So 128 minus 91 squared plus, okay, and then 122 minus 91 squared plus, and then 60 minus 91 squared, and then plus 64 minus 91 squared. Okay, I'm gonna do this. We're gonna do all the details here. Okay. All right. So, and then you are supposed to divide this whole thing. You know, this whole thing here. Oops. This whole thing by n minus 1. Right. N this n, that's just the size of the sample. The n, that's the number of data values, right? This is number, this is the size of the sample. Size of the sample. We have 6 lions, so the size of the sample is 6. So that's 6 minus 1 in the denominator. So this is 6, sorry. So this is 6 minus 1 in the denominator. All right. So this S squared. So first, we have 68. You have 68 minus 91, right? So that will be equal to negative. This is negative 23. And then there is a square. Okay. Plus 104 minus 91, right? So that will be equal to 13. So it's 13, and then there is a square. Plus. Then it's 128 plus, minus 91. So that will be 37, I think, right? 37. And then there is a square. Plus. Next, 122 minus 91. So that will be, I think, 31, the difference, right? So that's 31. And then there is a square plus, and then there is 60 minus 91, which is negative 31 squared. And finally, plus, there is a 64 minus 91, which is 27, negative 27. Negative 27, right, square. All right, and then this whole thing divided by, so this whole thing divided by 5, right? 6 minus 1 is 5. All right, so this is S squared. So just be careful, guys. Negative, when you have a square, negative, the square of a negative number, it's all positive. Okay, your S squared has to be positive. Okay, so a square of negative number has to be positive. So this 23 square or negative 23 square, sorry, that will be equal to positive 5. That's 529, all right? Plus, and then you have 13 square, which is actually 169. Plus, and then you have 37 square. Oops, 37 square, which is, let me see my notes, so 1369 plus 31 square. So that will be 961. Negative 31 square. Negative 31 square is the same as positive 31 square, right? Because as I said, with the square, the answer would be positive. So it's again 961 plus, and then the last the square, it's a negative 27. So that's negative 27 times negative 27. So that will be positive. Okay, it's always, the square is always positive unless it's 0. So that's 720. So this is 729 over this whole thing here over 5, right? And yeah, so then, so your S square, let me see. So we have 529 plus 169 plus 13 69 plus 961 plus another 961 and plus 7. Well, I have the final answer, but I don't have the, so 729. So that'll be 4,718. That would be great, guys, if you can check the answer with me at the same time using your calculator. So then divided by 5, of course. So this thing here divided by 5, so that will be equal to 943.6. Okay. So this is a S square, right? We need to compute F. Yes, please.
Do you want us to round off that number or leave it alone?
No, don't round up the answer, because, well, I mean, anyway, even if you round up the answer, the final answer, you know, at the end of the day, your answer is going to be very close to the,
Yeah, like
it's, yeah, the difference is very small. Yeah.
Yeah.
So I don't really mind. I mean, yeah. So then this second step 2, just take the square root, guys. So the S, your sample standard deviation S, it's the square root of this number. So square root of 943.6, right? Just be careful with the square root. It's not the square, it's the square root, okay? But anyway, so the square root of this would be, oops. So it's 30.
71.
Yeah, 71. Yeah, 30/17. Thank you. Okay. Yeah, that's exactly the answer. What did I say? The answer, right? It's 30. Where is it? Check. Where is it? Yeah, as you can see, it's, yeah, it's exactly the answer. 30.71 or 30.7, where. Yeah, it's just the same thing. All right. So yeah, that's your S. So you got your X bar, you got your S. So then you are done with A. Now question B. So in B it says, where is it? It says find 75% confidence interval. So find a 75% confidence interval for the population average weight for the population. So here population, we mean if you take all the mountain lions, right, and you compute their average weight. Okay, that's what we mean here by the population, the population average weight. Okay, average weight mu of all mountain lions, I don't know, in US or somewhere. Okay. All right. So 75 confidence interval. The 75, that's your confidence level, right? That's your C. So the 75, the confidence level is 75. 75%. Right? Now, we want to find the confidence interval. So confidence interval, as I said, it's always X bar minus E, X bar plus E. It's X bar minus E, X bar plus E. Now the question is sigma known or unknown? Sigma, that's the population standard deviation, right? So as you can see, guys, I mean, let's check the problem again here. So it says we have this sample of 6 mountain lions, their weight is etc., etc. So there is no sigma. We don't see any sigma here. So there is no sigma. Sigma is not given, right? There is no sigma. And then B, it says find the 75 confidence interval, etc. So there is no sigma, right? So there is no sigma, then sigma is unknown. There is no sigma in the statement. I mean, in the problem. All right, so then sigma is unknown. Okay, we don't know we don't have the value of sigma, right? We don't know what's the sigma, right? So sigma is unknown. Well, then, right? So we are in this case. So we are in the case where sigma is unknown. So then we need to use this formula for E. So this is the formula for the margin of error using this variable T, okay? So the E would be, so this T subscript C S over square root of N, okay? So because sigma is unknown, right? I know X bar, right? X bar, it's from A, sorry. X bar, you know, we know X bar, the average. We said the average X bar is 91, right? So there's no problem with X bar. It's given, or I mean, we compute the X bar. So the problem is with the E. And as I said, so the problem is with this E, and because sigma is unknown, then this E is actually equal to this T subscript C times S over square root of N. Okay. Any questions so far, guys? I mean, please let me know. I mean, yeah. And you'll see the difference when sigma is known. It's clear, like from the problem, you see that there's a sigma in the problem. So then your sigma would be known.
So T,
Yeah.
C, we get it from the DF/C. So
Yes, DF, yes. Yep.
Okay, I see number 70, but there's no 75.
Let me see.
Unless we're supposed to go where it says on the top, one
No,
tail.
no, no. No. Let me see if.
Or is it still table 3 on the bottom?
Oh, well, there is 75. Zero. Yeah, no, there is 75. The 0.75 next to 0.500.
0.75.
The next to the, so you have 0.500. So forget about the first and the second rows, right?
Okay.
So you have this DF or degree of freedom.
Oh, yeah.
There is a C.
Yeah, I see it.
Okay. All right. Yeah. So, yeah. So to find this T subscript C, we need to use this table number 4. And to use this table for number 4, you need your confidence level C, which is, we said 75%, and percent, that's division by 100. So that's 0.75 or 750. You can add 0 after 5 if you want. And then you're gonna need this degree of freedom, D dot F dot, which is simply the N minus 1. Right, so this is N is just the size of the sample. We have 6 lines, right? So that's 6 minus 1, that's just 5. So our C is 0.750 and degree of freedom is 5, right? So when we check the table right here, we need to go, so in the first column, you need to go to 5, okay? So 1, 2, 3, 4, 5. So you need to go to the 5, and then you need to check the top, your top. And again, guys, forget about the first and the second row, okay? So next to the DF, you have your C, which starts from 0.500, then 0.750, 0.800, etc. So if DF is 5 and C is 0.750, then the answer is 1.301. So yeah, so what I'm saying here, guys, there's this DF right here, and there is C, and you need to go to 5 right here, and then next to C here, there is 0.500. Is it 0.500? Sorry.
Yeah, it is.
Yes. And then there is 0.750, and then there's 0.800, 0.850, I think, etc. So we need, our C is 0.750 because it's 75%. So the answer is right here. The T subscript C, it's 1.301. What did I say?
301.
301. Thank you. 1.301. Right. So that's our T subscript C. So once you get your T subscript C, then you're done, right? Because S, that's what we computed in the A, right? And the N is just this N is equal to 6. So this margin of error E, so E would be equal to, so again, let me write down again the formula here. So it's 1.301 times S. S, that's the sample standard deviation, right? That's what we computed A. So it's 30.7 or 71. So times 30.71 over square root of N. N is 6. We have 6 lions, so it's square root of 6. All right, so let's compute this thing here. All right, so in the top, it's 1.301 times 30.71, and that will be 39.95, etc. over square root of 6. Okay, so that's 39.95 over square root of 6 is 2.44, right? And so this is, sorry, there's no C here. It's just E. All right, so yeah, I was saying, so it's just 39.95 over the square root of 6, and the answer is actually 16.30, I think. So it's 16, oops. This is 16.30. All right, so what we are saying here is that this margin of error E is 16.30. All right, and so the answer, the confidence interval X bar X bar minus E, X bar plus E. Our X bar sample mean, we said it's 91, I think. X bar, yes, 91. The sample mean, the average, it's 91. So it's 91 minus 60.3, and 91 plus 16, 16.3. And so then this is 1. So the answer is actually, yeah. So it's 74.7, and the other side, that will be 107.3. So that's your confidence interval. So that's the final answer. We are done. So as you can see, guys, the main thing to do here when we want to find this confidence interval is to compute this margin of error E. Okay. Once you have your margin of error E, then you know the confidence interval is just X bar minus E, X bar plus E. All right. Now, what does it mean? Again, this answer, I'm gonna just remind you again what we are saying here. So we have this confidence level 75%, right? So what we are saying is that we are 75% sure that the average weight of all the mountain lions is actually between 74.7 pounds and 107.3 pounds. Okay. So what we are saying here is that if you take, we are 75% sure, 75, that's our confidence level C. We are confident that 75% confidence, so C is confidence level. So we are 75% sure that the population weight, the average weight, so that the population average weight is between 74.7 and 107. Okay. Again, so this is the average weight of all the mountain lions, right? This is what we mean by the population mean or population average, all the mountain lions, because so we had this sample of just six mountain lions, right? It's just a sample. The X bar is just the sample mean, right? But this is here we are talking about the average weight of all the mountain lions, not just the six we had in the sample. All right. Any question, guys? I'm gonna check the chat, see if there are any. Okay. Nothing in the chat. All right. So this is the case when sigma is unknown, right? The population standard deviation is not given in this problem. There's no sigma here, right? It's not given in the problem, right? So like again, it says we have the sample, six mountain lions, etc. There's a sample, the weights, etc. So there's no sigma here, right? Now, let's take another example where sigma is given. So let's have an example from the textbook exercise from section 8.1. So all right, so here is exercise 16, for example. Exercise 16, page 382. All right, so in this problem, it says the following. So it's about, I don't know what it is, but it says, so it's about uric acid. So it says, so patient has taken 8 blood tests for uric acid, and the average was, so a patient has taken 8. Okay. 8 blood tests for uric acid. Anyway, so it says the mean concentration was, so the average, the sample mean, so we have this 8 tests, so the average or the mean, the average concentration was X bar equal to 5.35 milligrams, I guess, per. I don't think, yeah, I think it's a milliliter or deciliter. Anyway, so it's 5.35, and then it says the distribution of uric acid is can be assumed to be normal with sigma equal to the distribution of uric acid in healthy adults can be assumed to be normal. Can be assumed to be normal, and then to be normal. Okay, and then it says with sigma. With sigma, the population standard deviation sigma is actually 1.85 milligrams per deciliter. All right, and then the question is, there is only one question here. Well, in A, it says find 95% confidence interval interval for the population mean concentration of uric acid in this patient's blood. So find 95% confidence interval for the population mean mu, of course, concentration of uric acid in this patient's blood. All right. So, well, you see here, we need to find the confidence interval, right? And there is this 95%. So whatever percentage you have before the confidence interval, that's your confidence level, right? So this is your confidence level C. Right, so this is your confidence level. Confidence level. All right, so we need to find the confidence interval. So as I said, confidence interval means confidence interval. That's X bar minus E. That's X bar minus E. X bar plus E. So the X bar, it's given in this problem, right? It says this, you have the X bar mean concentration. So this patient took 8 blood tests for this uric acid, and then the sample mean was 5.35. So X bar is given, right? So difference with the previous exercise, well, the X bar, well, we had this sample of 6 lions, and then we had to compute the X bar, right? Because we have a sample, you have the data values, then you can compute the X bar, you can compute the average. So here the average was given, right? So there was no sample here. We have the X bar, it's already given. So we know X bar. So this is given. All right, so again, the problem is with the E, the margin of error, right? Right, so we need to find the E. Now, what would be the formula for E? So here in this case, so the question, of course, is sigma known or unknown? Well, as you can see, sigma is given, right? Sigma is right here. Their population standard deviation is given, right? So this is different from the previous example with the mountain lions. There was no sigma, right? I mean, there was this sample of 6 lions, and then you need to find the confidence interval. So there was no sigma, nowhere. Okay. So here we had sigma, and when you have sigma, so we said, let me just again just show you here in the what we said in the beginning of the lecture. So we said when sigma is known, so we use actually normal distribution. So we can use this the Z, the variable of the standard normal distribution, and this is your margin of error. It's this Z subscript C sigma, because sigma is known, so we can use sigma over square root of n. Okay, so here our E would be, so our E would be Z subscript C times sigma over square root of n. Sigma is given, it's right here, square root of n. So that's the size of the sample. So this patient has taken 8 blood tests, right? So the sample is the size of the sample here is 8, right? Because we have 8 different blood tests, right? So the sample is 8. The size of the sample is 8, right? So n is 8. Or n is 8. Right? So all you have to do is to find this Z subscript C. Right? So this Z subscript C. And how do we find this Z subscript C? Well, we use the table, the bottom of table phi, right? So this is where you use the bottom of this table phi.
1.96.
With the confidence level C, you know that C is 95%. Okay, C is 95%. So let's go to the bottom of the table phi. So this is table 4. Yeah, right here. In the bottom of the table phi, C is 95%. So as you can see, when C is 95%, corresponding critical value is 1.96, right? So it's 1.96. So this Z is just 1.96 from the table. And then you are done, because now we can compute the margin of error E. So it's 1 point. So again, let me write down again the formula. So it's times sigma over square root of n. Z subscript C, the critical value is 1.96 times sigma. Sigma is given. It's right here, 1.85. 1.85 over square root of size of the sample. We have 8 different blood tests, so a square root of 8. All right, so yeah, just multiply the top. Let me just check my notes for the answer for this. I think I have the top. So let me see, where is it? Yes, yeah. So it's it's a 3 point. So the top, that's 3.626 over square root of 8. Square root of 8 is actually 2.82. Okay. So yeah, so the answer is actually, let me see. So yes, so it's 1.28. Let's say 1.28. So yeah, so you got your margin of error. Once you have your margin of error, now we can, so we can answer the question, right? X bar minus E confidence interval. So X bar minus E, X bar plus E. As I said, there's no problem with the X bar. It's always given. Like in whenever you have to find this confidence interval, X bar, it's either given, or you can compute the X bar from the sample, right? Like the example we had with the mountain lions, right? So you can compute their average weight. So X bar is not a problem. So here X bar, it's 5. As you can see right here, it's 5.35. And so this is 5.35 minus E, and the other side it's a plus 8. So see the answer. So here it's, yeah, it's actually equal to 4.07, comma, and this is 5.5 plus. Yes, so this is actually equal to 6.63. Right. So that's your confidence interval. And again, the interpretation, guys, what we are saying here is that the population mean, the population average belongs to this. The probability that the population mean belongs to this interval is actually 95%. Okay. Any question? So actually, this is, I mean, both, as you can see, this is actually the difference between the two sections, 8.1, 8.2. Okay, and these two exercises, like, they are like, you know, this like this standard problems you can have. Yeah.
So for the one that doesn't have the unknown factors, do we always have to find the standard deviation? Or is it to be given?
All right. So, well, okay. You're talking about the sample standard deviation S, right?
Yeah, just the S.
Yeah, the S. Yeah. Well, because this is an exercise from the textbook, right? But in general, like in the test or in the final, because here the point is not really computing the S, because we did that like in the chapter 3, right?
Right.
So yeah, so in the test or in the final, the S would be given. Okay. So you won't, because otherwise, you know,
it's using another chart. Really.
Yeah, yeah, and it takes like I get a lot of, I guess, a lot of time actually to compute this. Yeah,
that's
yeah.
exactly what I'm asking.
But but the thing is, because we are doing this exercise, this is an exercise from the textbook, right? So
Yeah, no, that's fine. It's good
yeah,
to practice anyways. Like if I
yeah,
had
yeah, yeah. Mhm. Um, all right. Any other question? Uh, yeah, I think so. The next homework, guys, we'll have probably, I guess, two exercises, two problems, very similar to those two exercises here. Okay. Um, yeah. Anyway, so let me see the chat if there's any. Okay, chat. All right. All right. What we can do now? Yeah. So this covers. I mean, we're done actually with this section 8.2. Um, so, well, we can move to the section 8.3. Yeah, well, okay, let's start with 8.3. Well, we have like I don't know, 25 minutes. Yeah. Well, I'm not sure if I don't think I'm gonna finish 8.3 today, but anyway, yeah. So let's move to the 8.3. So 8.3, it's gonna be about, again, this binomial distribution. So well, so this is section 8.3, and in this section, we're gonna do another estimation, but it's not this an estimation of the population mean, but we're gonna try to estimate the probability of success P in a binomial distribution. Remember, we have this binomial distribution where we have like two outcomes, you know, probability of success, probability of failure, etc., right? And the probability of success P, it was always given in the problem, right? So now the question is, what do we do if the probability of success P it's not given, right? So we're gonna try to find an estimation of this probability of success P. Okay, like what we did in the 8.1 and 8.2, trying to estimate this population mean mu. All right, so yeah, 8.3, it's about the binomial distribution, and so here we're gonna try to estimate estimating the probability of success P. Probability of success. All right. So I'm gonna remind you first, just very quickly, what's a binomial distribution. Remember, we said for binomial distribution we had distribution. We had two possible outcomes of interest. There's a success, capital S, a success, and there is capital F, failure. Right, two outcomes, either success or failure. There is P, which is supposed to be equal to the probability of success, and there is Q, which is equal to the probability of failure, which is always 1 minus P, right? Q is always 1 minus P, and there's N, which is the number of trials, and there is R, which is number of successes. So let me just remind you that, you know, in section or chapter, you know, in chapter 6, so sections 6.2 and 6.3. So in 6.2 and 6.3, we computed the probability of success R when N, you know, N is, is small, right? what I mean here by small is, we use the table number 2, right? The table 2, and in the table 2, the largest value of n was 20, right? So to use the table, your n has to be less than 20. Now, and then in section 7.6, right? So this is size 3 and 4 in the homework, and the last homework. So in this section 7.6, we computed this probability of successes, or probability of R successes, and when n is large, we said in that case, when the number of trials n is large enough, then we can approximate this probability of successes with the binomial, with the normal distribution, right? When n is large. So this probability of successes can be approximated with the binomial, with the normal distribution. So it can be approximated. So we can convert this R to Z, right? By a normal distribution. All right. All right, now, so in this section 8, this section 8.3, the question is, well, the problem here is, so in this section, we're gonna try to see, or we're gonna try to estimate the probability of successes, the probability of success P, right? So the question is, so what happens when P is unknown, right? So if P is unknown, if the probability of success P is unknown, if the probability of success is unknown, can we find an estimation of P as probability of success? Of P, probability of success. All right. All right, guys. So the idea here would be to try to estimate this P using, so we're gonna try to use a sample. So let's say, so the hypothesis here would be so the following, we're gonna have the following hypothesis. So first, as I said, P is unknown. P is unknown. The probability of success is unknown. Okay. And then we have a binomial experiment. We have a binomial experiment with n trials. So the number of trials here is known. So the number with n, the number of trials, and number of successes is known here, and R, number of successes, is given. Is given. Okay. So let me give you an example. So example. All right. let's say you have a random sample of 188. So random sample of 188 books. Okay, 188 books bought at a bookstore. Bookstore. And out of the 188, we know that 66 books were murder mysteries. Okay. So suppose P is the proportion of books sold by the bookstore so by the bookstore that are murder mysteries. Okay. So the idea here, guys, is that so this P is so when you take a book, okay. So if you take a random book, right? So either the book is, let's say here we are interested in murder mysteries, right? So either the book, if you take a random book, either the book is a murder mystery, so murder mystery, or so that will be, let's say that will be a success, okay, or it's not, okay, and that will be a failure. Okay, now, so when you go to this bookstore and you pick a random, you pick a random book, okay, you pick a random book. So what's the probability that the book is actually a murder mystery? Well, we don't know, right? It's not given here. If you go to this bookstore and you pick a random book, okay, you don't know the percentage or the probability that the book is a murder mystery. So the probability of success here, the probability that you pick a murder mystery is actually unknown, right? So here, so like in this example, so the probability of success P, probability of success is unknown. Okay. So all we have here in this problem is we have this sample, just a sample of 188 books, right? The 188 books, they're not all, they don't represent all the books in the bookstore, right? There are thousands of books in the bookstore, right? More than 188 for sure, right? This is just a sample. This is not all the books in the bookstore, right? They don't represent all the books. This is just a sample, right? This is a sample. So we have this sample of 188 books, and turns out that out of the 188, 66 are murder mysteries, right? So we don't know what's the probability of success. We don't know what's the probability that if we pick a random book, that the book is actually a murder mystery. We don't know what's the probability of success, right? So the probability of success P is here in this problem is unknown, right? So probability of success P is unknown. However, we know that we have this sample. We have a sample of 188 books, right? And out of the 188, how many successes? Well, success is when the book is a murder mystery. That's what we mean by success here, right? When the book is it's a murder mystery, right? So out of 188, there are 66 books, which are murder mysteries. So there are 66 successes out of 188. So we have, there are 66 successes, right? So again, by success here, I mean a success, that's when the book is a murder mystery. Okay. So the proportion of the proportion of success here. So the proportion of success. So in this sample, so it's actually denoted by p hat. Okay. So this is, P is probability of success, but this proportion of success, it's not exactly P, right? This is a different thing. So proportion of success, it's just the number of successes. This is just the number of successes in the sample, number of successes in the sample over the size of the sample. Okay, so that's what I mean by the proportion of successes here, or proportion of success. So just the number of successes over the size of the sample. So like here in this, we have this sample of 188 books, and it turns out that 66 are murder mysteries. So the proportion of success here, p hat. So this p hat, this proportion of successes, a proportion of success is actually equal to proportion of success in this sample is 66, because we have 66 murder mysteries books out of 188. So just 66 over 188. Okay. But this is not, this proportion of success, this is not the probability of success. Because again, we got this proportion of success using this sample of 188 books, right? So, but we don't know how many, we don't know how many murder mysteries books in the whole bookstore, right? So this proportion of success, or proportion of success is p hat. This p hat is different. So just careful here. P hat, it's not p. It's not the probability of success. Okay. So once you have the sample, you can compute this proportion of success. You have your size of the sample, and you know how many successes you have in your sample. So then you can compute this proportion of success. All right. Let me give you another example. Example 2. Example 2. All right. Let's say we have so we have a group of, let's say 20 New Yorkers. Okay. And actually, let's say 12. So out of the 20, 12 and 12. So we know, so we have a group of 20 New Yorkers. We know that 12 out of the 20, let's say, got, let's say, COVID. Okay. So let's say the success here, probability of success. So success here is that, so success, this is when a New Yorker, say a New Yorker. So when you pick or select a random New Yorker, so you select a random New Yorker. So of course, there are two possible outcomes here because we are interested in if the person got COVID or not, right? So if you select a random New Yorker, so either the person got the COVID, let's say, and that will be a success, or the New Yorker didn't get COVID, right? So that would be, let's say, a failure. Okay. Now we don't know what's the probability of success. So if you select a random New Yorker, you know, there are 10 million New Yorkers, I guess. So we don't know what's the probability of success. So if you select a random New Yorker, we don't know what's the probability that the person got COVID, right? Now, so the probability of success here is unknown. So P, the probability of success is unknown. However, well, what we have here is just a sample of 20 New Yorkers. So we have this group of 20 New Yorkers, right? 20 New Yorkers. And in this group, we know that 12 out of 20, they got COVID, right? So in this sample, the proportion of success, so in our sample of 20 New Yorkers, the proportion of success, so the proportion of success P hat, so P hat, so again, P hat is just number of successes over the number or the size of the sample. Size of the sample, or the number of trials. Number of trials. So in our sample, we have 12 successes, right? 12 people who got COVID, so it's 12 over, and it's a group of 20. So the size of the sample we have is 20, so it's number of trials is 20, so 12 over 20. Okay, so this is your P hat. That's your proportion of. So this is what I call the proportion of success. Proportion of success in our sample. In the sample. Okay. All right, guys. So tomorrow, not tomorrow, but sorry, the next week, I guess. Yeah, next week, we'll see how to use this proportion of success or proportion of successes to get an estimation of the probability of success P. Okay, so next week, I guess, because we don't have time now, of course. So we will use P hat to get an estimation of probability of success P. To get an estimation of, so you're using the sample to get an estimation of this probability of success, like in general, in the whole population, right? An estimation of P. All right, I'm gonna stop here, guys. Hopefully I'm gonna see you next Monday. And as I said, so next week I will post the review sheet for the second test. And this section 8.3 is kind of short. It's just, the idea is the same. We're gonna have this confidence interval, same. It's just a different way to compute this margin of error E using this P hat, and then there are like two sections I think left in chapter 9. All right, thank you for listening, everyone, and hopefully I'm gonna see you next week.
Bye, Professor. Have a nice one.
You too. Thanks.
Bye, Professor. Thank you.
Bye-bye. Bye-bye, Edward. See you.